Imagine this. You wake up tomorrow morning with the power to travel at the speed of light. 186,000 miles per second. The universe suddenly becomes your playground. But here's the catch. You only have a human lifetime to explore it. 50 years of light speed travel. Sounds like enough time to see everything, right? Wrong. The universe is so incomprehensibly vast that even traveling at the fastest speed possible, you would barely scratch the surface of cosmic exploration. Today, we're taking you on the ultimate journey through space. We're going to show you exactly where you could go, what you could see, and what would forever remain beyond your reach if you could race through the cosmos at light speed for half a century. Buckle up. This is going to blow your mind. Let's start with something familiar. Earth, our home. If you could travel at light speed, you could circle the entire planet 7.5 times in just 1 second. 1 second. The distance from New York to Tokyo, from the North Pole to the South Pole, all of it would become meaningless. You could have breakfast in Paris, lunch in Sydney, and dinner on the International Space Station without breaking a sweat. But we're not here to talk about Earth. We're here to talk about the universe. So let's zoom out. Your first stop is the moon. At light speed, you'd reach our celestial neighbor in 1.3 seconds. That's faster than you can say, one small step for man. The Apollo astronauts took 3 days to get there. You'd be there before your coffee gets cold. But the moon is just the beginning. Let's keep going. 8 minutes and 20 seconds into your journey, you'd pass the sun. That's right. The light that hits your face every morning has been traveling for over 8 minutes before it reaches you. The sun, that massive ball of nuclear fusion that makes all life on Earth possible, would be just a brief checkpoint in your cosmic road trip. But here's where things start to get interesting, and a little lonely. After passing the sun, you're in deep space. The next significant landmark? Venus. Then Mars. At light speed, Mars is about 3 minutes away when it's closest to Earth, and 22 minutes when it's farthest. You could visit both planets in less time than it takes to watch a sitcom episode. Jupiter, the king of planets, would take between 32 and 52 minutes, depending on orbital positions. Saturn with its magnificent rings? About an hour and a half. Uranus and Neptune, the ice giants at the edge of our solar system, would take roughly 2.5 and 4 hours respectively. So let's do some quick math. If you spent just 1 day touring our entire solar system, visiting every planet, checking out some moons, maybe swinging by a few asteroids, you'd still have nearly 50 years of light speed travel left. Sounds promising, right? Now here's where the universe humbles us. The nearest star system to our sun is Alpha Centauri. It's actually a triple star system, and it's the closest stellar neighbor we have. How far away is it? 4.37 light years. That means even traveling at light speed, it would take you 4 years, 4 months, and about 12 days to get there. One way. Just to reach the nearest star system. Suddenly, 50 years doesn't seem like that much time anymore, does it? But let's say you make that journey. What would you find at Alpha Centauri? 3 stars orbiting each other, and at least 2 confirmed planets. One of them, Proxima Centauri b, orbits in the habitable zone. It might have liquid water. It might be capable of supporting life. You'd be the first human to ever set foot in another star system. The first to see an alien sunrise. That moment alone might be worth the 8.5-year round trip. But you still have over 40 years of light speed travel remaining. Where else could you go? Let's talk about Barnard's star. 6 light years away. Sirius, the brightest star in our night sky. 8.6 light years. Epsilon Eridani, a young star that might have its own planetary system. 10.5 light years away. You're starting to see the pattern. The universe spaces things out. A lot. Within a 25 light-year radius of Earth, there are about 80 star systems. Some are single stars like our sun. Others are binary or triple systems. A few have confirmed exoplanets. With 50 years of light speed travel, you could theoretically visit all of them and still have time left over. You could explore dozens of alien worlds. You could study different types of stars up close. Red dwarfs that burn slowly for trillions of years. White dwarfs, the dying remnants of stars like our sun. You could witness stellar phenomena that we can only imagine from Earth. But let's think bigger. What about famous stars we can see from Earth? Vega, one of the brightest stars in the summer sky. 25 light years away. You could just barely make it there and back in your lifetime. Arcturus, the 4th brightest star in our night sky. 37 light years away. One-way trip only. Pollux, one of the twins in the Gemini constellation. 34 light-years. Fomalhaut, with its spectacular debris disk that might be forming planets right now. 25 light-years away. Notice something? All these famous bright stars we see from Earth, the ones that have inspired humanity for millennia, the ones that ancient civilizations used for navigation and mythology, most of them are at the absolute edge of what you could reach in a 50-year light-speed journey. And we're only talking about round trips for the closest ones. Now let's talk about what you definitely could reach if you only went one way. 50 light-years out from Earth. What's out there? You could reach Tau Ceti, a star remarkably similar to our Sun with at least 4 planets. 11.9 light-years away. You could visit 61 Virginis, another Sun-like star with at least 3 planets. 28 light-years. You could explore the planets around HD 40307, a star with a super-Earth in its habitable zone. 42 light-years away. You'd be pushing your limits, but you could make it. The Trappist-1 system, remember that? The system with 7 Earth-sized planets, 3 of them potentially habitable. It made headlines a few years ago. 39 light-years away. You could spend your final years exploring the most exciting planetary system we've discovered, walking on worlds that might harbor life, seeing things no human has ever seen. But here's what you couldn't reach. Betelgeuse, that massive red supergiant in the constellation Orion that could go supernova any day now. 550 light-years away. You couldn't even make it a tenth of the way there. Rigel, the bright blue supergiant also in Orion. 860 light-years. Not even close. The Pleiades, that beautiful star cluster you can see with your naked eye. 440 light-years. Sorry, too far. And we haven't even talked about the really exotic stuff. The Crab Nebula, the remnant of a supernova that exploded almost 1,000 years ago. 6,500 light-years away. The Orion Nebula, the closest region of massive star formation to Earth, a stellar nursery where new stars are being born right now. 1,340 light-years. You couldn't reach it in 10 lifetimes of light-speed travel. The Eagle Nebula with its famous pillars of creation. 7,000 light-years. The center of our Milky Way galaxy with its supermassive black hole. 26,000 light-years away. Let's put this in perspective. Our Milky Way galaxy is about 100,000 light-years across. In 50 years of light-speed travel, you could only cross half of 1% of our galaxy's diameter. Half of 1%. The Milky Way contains an estimated 200 billion stars. With 50 years at light speed, you might be able to visit a few hundred of them if you rushed. That's 0.0000002% of the galaxy. Basically nothing. And the Milky Way is just one galaxy. There are an estimated 200 billion to 2 trillion galaxies in the observable universe. The Andromeda Galaxy, our nearest large galactic neighbor, is 2.5 million light-years away. The light we see from Andromeda left that galaxy when our ancestors were learning to walk upright. You would need 50,000 lifetimes of light-speed travel just to reach it. The observable universe, the part we can actually see, is 93 billion light-years across. If you traveled at light speed for 50 years, you would cover 0.00005% of the observable universe's diameter. You would be a grain of sand on an infinite beach. A drop of water in all the oceans of Earth combined. But here's the beautiful part. Even though you could only explore this tiny bubble around Earth, what you would see would be extraordinary. Every star you visited would be different. Some would be young and hot, burning blue-white and spinning rapidly. Others would be old and cool, red giants swelling up as they approached the end of their lives. You'd see binary stars dancing around each other, locked in gravitational embrace. You'd witness planets of every type imaginable. Gas giants larger than Jupiter. Rocky worlds smaller than Mercury. Ice worlds covered in frozen methane. Lava planets where the surface glows red hot. Ocean worlds completely covered in liquid water. You might find life. Even in our small 50 light-year bubble, there could be dozens of worlds with microbial life. There might be a world with complex ecosystems, alien forests, alien oceans teeming with creatures we can't even imagine. And if we're really lucky, maybe, just maybe, you'd find another civilization. Another species looking up at their own stars, wondering if they're alone. Imagine being the human who makes first contact, who proves once and for all that we are not alone in the universe. You'd also witness cosmic violence. Stars don't last forever. In 50 years of exploration, you might witness a supernova. A star exploding with the force of 1 billion nuclear weapons, shining brighter than an entire galaxy for a few weeks. You'd see it from a safe distance, of course, but you'd witness the birth of a neutron star or possibly a black hole. You'd see stellar collisions, planets being torn apart by tidal forces, comets smashing into worlds and changing their destinies forever. And through it all, you'd be alone. Even at light speed, communication would be impossible. A message sent back to Earth from 25 light years away would take 25 years to arrive. By the time Earth received your message and sent a reply, 50 years would have passed. You'd be at the end of your journey, and the Earth you left would be a half-century older. Everyone you knew would be elderly or gone. The world would have changed in ways you couldn't imagine. This is the cruel irony of light speed travel. Even at the fastest speed in the universe, the cosmos is simply too big. Space doesn't just separate places. It separates time. At light speed, you could reach new worlds, but you could never truly come home. Earth would be a memory, a blue dot in your rear-view mirror, forever receding into the past. But maybe that's okay. Maybe the point isn't to see everything or to conquer the universe. Maybe the point is to be humbled by it, to understand our place in the cosmic order. We are not the center of anything. We're not special in terms of location or destiny. We're residents of an ordinary planet around an ordinary star in an ordinary part of an ordinary galaxy. But we're the residents who looked up, who wondered, who dreamed of touching the stars. If you could travel at light speed for 50 years, you'd barely leave your own neighborhood in cosmic terms. You wouldn't reach the Orion Nebula or the Crab Nebula. You'd never see a quasar up close or fall into a black hole. You'd never reach another galaxy. But you would see things that would change you forever. You would walk on alien worlds. You would see 100 different suns rise. You would float in space and look back at Earth from dozens of light years away, seeing our planet not as it is, but as it was decades ago, the light carrying images from the past. And maybe, if you're very fortunate, you'd discover that we're not alone. That life finds a way everywhere. That the universe isn't cold and empty but vibrant and full of possibilities we haven't yet imagined. So where could you go in your lifetime at light speed? The answer is both everywhere and nowhere. You could explore a bubble 50 light years across, a sphere containing thousands of stars and potentially millions of worlds. You could see things that would make you weep with joy and terror. But you'd also realize that the universe is playing a game on a scale we can barely comprehend. That even our wildest dreams of exploration are constrained by the laws of physics and the vastness of space. The universe is not designed for us to conquer. It's designed to inspire us, to remind us that we're part of something much, much bigger. And in that humbling realization, there's a strange kind of peace. We may never travel at light speed. We may never leave our solar system. But we can still look up, still wonder, and still dream. And maybe, just maybe, that's enough. Thank you for joining me on this journey through the cosmos. If this made you think differently about our place in the universe, hit that like button and subscribe for more mind-bending explorations of space and science. The universe is waiting. Even if we can't reach it all, we can still appreciate its infinite beauty.